A leaking fuel tank is hazardous. When a fallen tree branch scraped our plastic Jeep Cherokee fuel tank on a 4x4 trail run, we were fortunate. The tank didn't rupture. However, the scrape was deep enough for a potential leak. Mopar has discontinued these tanks, and there are no direct replacement aftermarket tanks available for 1997 to 2001 Jeep Cherokee 4x4s. The alternative is either a used tank from a donor vehicle or an $1,800 oversized capacity aftermarket metal tank with a built-in skid plate. Repairing this scrape became the goal. Polyethylene and polypropylene plastics are challenging to repair. The usual go-to products for bonding plastics state flatly that they will not bond to high-density polyethylene, commonly known as HDPE. An HDPE fuel tank repair must be a permanent bond, remain flexible, and tolerate vibration. Epoxies and glues simply cannot achieve this. Worse yet, they will not adhere adequately to HDPE, LDPE, and similar polymers. Given the requirements of an automotive fuel tank, we chose this molecular bonding process for its flexibility, strength, and fuel resistance. We picked the Tech-Bond polymer bonding process based on the manufacturer's data and recommended uses. To tolerate higher octane gasoline, we opted for the PTFE Teflon overlay patches. We elected to do this work with the tank still in position. The tank material was very thin at the scrape, but after a month showed only a slight sign of fuel permeation at the damaged area. There was no visible leaking or wetness. This was still not a full crack or puncture, but could quickly become one. According to Tech-Bond Solutions, the polymer bonding process repairs holes, full cracks, and more severe damage than our tank. The dry condition of the scrape made a tank in position repair possible. Our challenge was the overhead repair. Tech-Bond has a library of how-to videos available at its website and YouTube. Instructions are available in the kits and also at the Tech-Bond website. We strongly advise users to consult with Tech-Bond Solutions when a repair is unique. This is a system that requires specific steps. We studied the Tech-Bond guidelines and applied them wherever possible. The repair demonstrated in this video is based on our choice to leave the fuel tank in position, which could be necessary during repairs in the backcountry. We considered the dangers and hazards of fuel leakage and risks of flammable and explosive fumes. This process involves applying heat carefully with temperature control and monitoring. We did not use an open flame. We avoided spark generation of any kind. No hot tools touched the tank's surface. We kept the heat gun's nose away from the tank surface. For proper chemical reaction, peak heat applied to the tank surface was warm to touch, or 120 degrees Fahrenheit as described in the manufacturer's detailed instructions and videos. When using any repair method on a gasoline or diesel automotive or truck fuel tank, a motorcycle, ATV, UTV, or even a fuel can, use extreme caution and safe practices. Before performing Tech-Bond Solutions' polymer bonding process, read all instructions. Contact the manufacturer with further questions or concerns. While we saved considerable time and costs by repairing an obsolete fuel tank, this work must be performed with due caution. Tech-Bond Solutions emphasizes that these repairs are a permanent fix when performed properly. To date, our results have been a quality, leak-free repair. A heavy-duty fuel tank skid plate is on the accessory list for our Jeep XJ Cherokee 4x4. The installation of a skid plate will be a priority before we go off-roading again. High-density polyethylene is a thermoplastic polymer. It's made from petroleum and used in a wide variety of industry applications from plastic bottles and milk jugs to the fuel tanks in our motor vehicles. LDPE is low-density polyethylene. EVOH is a liner that helps eliminate permeability. EVOH is a copolymer of HDPE. This material is flexible and tough, and these surface scratches are not of any consequence. This scrape from a fallen tree limb in a trail is another story. HDPE tanks are not that thick. This scrape is deep enough to be concerned. Although not yet leaking, there are signs that it's ready to rupture. Filling this scrape with SI adhesive and then patching it will be the fix. The G-Series Tech Patch Economy Poly Kit works with lower octane gasoline. For substantial support, we went with the Teflon patches that are resistant to high-octane gasoline. The PTFE goes against the tank substrate. The chemistry of this system creates a molecular bond and also a polymer bond. Strength comes from the covalent bonding. Bonding is always superior to gluing. We'll begin by smoothing out the surface of the scrape area. This is done with a DA using a very slow speed. The disc is a 3M stick at 150 grit. The disc is operated on an angle at the edge of the disc to remove just the protruding material from the scrape. To control and minimize the removal of material, the emphasis is strictly on the area of the scrape. Each step of the way with this project, we're constantly aware that there is not another new tank available, and that if repaired properly in position, this will save a tremendous amount of labor. A big plus with plastic tanks is that they don't corrode. Finding a good use one is not impossible, although it would require cleaning and transferring of parts like the fuel pump module and all of that. Here we size up the fitment of the patch. The tank has some strange angles, and it's important to get the minimal amount of curvature as the patch squares up with the tank. This is the angle that works best, with a Teflon patch covering and centered over the damaged area. The perimeter of the patch is marked with a felt tip pin to enable sanding the minimal area. Still working the edge of the DA sanding disc, control of the sanding is much easier. Air-powered, the DA is much easier to hold to slow speeds. We could go with a milder disc and speed up the operation, but this seems to be working well. Roughing up the surface could actually be done with the sandpaper included in the kit. In the field, that might be the sensible solution. However, we do have the DA sander, and look at the smooth and consistent finish we can get with this tool. Time and care spent here will make all the difference in the outcome of this project. Like body and paint work, everything depends on the preparation. All residue must be removed. For this type of plastic, I'm using acetone. Many plastics are incompatible with acetone. Be thorough and be certain to remove all residue and allow the acetone in this case to dry completely. Here, the acetone is evaporating rapidly. We now have a clear sense for the extent of the damage. We'll get a precise measurement of the depth of the scrape. Here's some perspective on how the scrape affects the thickness of the tank. We thank Olympus Industrial Resources for this information. At the deepest point, it is 36 thousandths of an inch, or 0.93 millimeters. If this tank is only 2.5 millimeters thick, and 0.93 of that is a scrape, we don't have much material left. Here we use a shop's clean air source for final cleaning of the surface before prepping for the patch. This is a shop's HDPE air dryer system. The tech patches are made of fluorosilicone, part of the TPRS system. They come treated with polymer prep adhesion promoter, which enables a strong bond that would not otherwise be possible. Applying the patch begins with the polyprep adhesion promoter. We saturate the area with polyprep, paying close attention to the damaged scrape. The goal at this point is to fill the scrape with SI adhesive in layers and then ultimately put a patch over the entire area. Allow the polyprep to dry thoroughly. This will not take long. Next, we apply the Tech-Bond Activator Accelerator. Applied to a dry surface, the activator accelerator also dries quickly. Allow the accelerator to dry. This will enhance the activation of the adhesive. For this repair, we're using the SI adhesive in layers as a filler for the scraped area. The patented polymer bonding process bonds a poly to itself, to other polys, and or to other substrates. It will not bond glass, stainless steel, or alloy steels. Here we apply heat carefully with a heat gun. The surface temperature will not be allowed to get past 120 degrees. This is Fahrenheit measured with a non-contact thermometer. Do not use an open flame or any kind of spark-generating device. Warm to touch is sufficient for activating the adhesive. SI adhesive stands for Surface Insensitive, an adhesive system that will work on all materials except for glass, stainless, or alloy steels. SI Black is part of the kit. Here, the first layer goes into the scraped area. The polymer bonding system has distinct steps that must be followed carefully. The polymer bonding process is effective and works well if performed properly. Of course, this repair would be much easier to perform if the tank was upside down. Here, we're able to fill the scrape because the bonder adhesive is somewhat thicker than a runny liquid. SI Black adhesive is still liquid. Though not a gel, the liquid is thick enough to adhere in this position. This is the first layer of SI Black adhesive. The surface temperature will now be raised with the heat gun. This will help the activation process. Note that the gun is held well away from the surface of the fuel tank. The goal, again, is warm to touch, with a maximum temperature around 120 degrees Fahrenheit. Follow the directions carefully. They are provided in each of the repair kits from Tech-Bond Solutions. Now we spray the surface with accelerator activator. The warmed surface contributes to the chemical process underway. Activator accelerator is now applied to the surface. This accelerates the curing of the SI Black adhesive. The temperature is raised once more to warm to touch. The target temperature is 120 degrees Fahrenheit. Now, another layer of SI adhesive black is applied with the squeegee that comes with the kit. The SI black adhesive is used as a filler in this case because of its flexibility, which is better suited to the fuel tank that expands and contracts. The rigidity of epoxies and even some glues make it impossible to flex with a fuel tank. This is one more reason why the Poly PTFE kit is our choice for this kind of repair. The surface is once again brought to temperature before the adhesive accelerator is applied. The activator accelerator is an essential part of this chemical process. Once the activator accelerator has dried, a curing process is underway and more activator accelerator is applied. This chemical reaction creates a strong and flexible bond. Warm to touch sets a thermal process in place. The chemistry is now at work. Now we get ready to install the patch. This begins with the poly prepping of the area, a broader area in this case to accommodate the full area of the patch. Allow the poly prep to dry. This won't take long. Now apply the Tech-Bond Activator Accelerator. Allow the activator accelerator to dry. Again, this won't take long. Here, the activator accelerator is drying in real time. Add heat once more, just enough to be warm to touch, or 120 degrees Fahrenheit peak. Now we apply a coating of the SI black adhesive to the Teflon side of the patch. The adhesive is applied in a circular motion and will eventually fill the entire surface uniformly. No gaps, no open spaces. This must be a thorough coat of adhesive. Only 2 areas are left void of adhesive. That would be diagonal corners for applying the patch, putting it into place without it sticking to your fingers. The adhesive over the center of the patch will join up with the adhesive that is already cured in the scraped area. Here we apply the patch very carefully, laying it into position one time. The center of the patch straddles the scraped area. Spreading and pressing inward on the patch and holding in place for 15 or more seconds will get the patch to adhere to the surface. Quickly begin spreading and pressing down on the patch to make sure that it's flat against the surface of the tank. Work pressure initially from the center of the patch outward to the edges. The kit's squeegee is helpful for this process, making it much easier to spread evenly. Make sure the pressure is toward the tank to keep the patch flat. Beneath this patch, where the Teflon meets the tank, a chemical process is taking place. This is a molecular as well as polymer bonding process. The durable, high-strength patch will stay in place. Thoroughly bonded, the 2 mm thick FVMQ patch with additional thickness of Teflon is substantially thicker than the depth of the scrape. Tech-Bond uses fluorosilicone as their polymer of choice. During the manufacturing process, a surface of fluorosilicone is infused with side groups that strengthen the chemical and physical resistant properties of fluorosilicone. With these enhanced properties, the Tech patches have an excellent fuel, oil, water, and weather resistance, resistant to most chemicals. Polyfluoroalkyl side groups protect the fluorosilicone from damage from water, weather, gas, oil, all hydrocarbons, salt, and humidity. Several coats of SI black adhesive will be layered over the top of the patch. The perimeter is thoroughly sealed, then sprayed with activator accelerator. Considering that we chose to perform this repair in place, this is going smoothly. For an extensive overlanding trip, this kit would definitely be on board. A plastic HDPE fuel tank or gas cans of polyethylene could be repaired in the field. This could be a compact emergency first aid kit for fuel tanks. Note the role that the activator accelerator plays. After each of the applications of SI black, accelerator is applied. This activates the chemical bonding process. Follow the steps outlined in the Tech-Bond instructions that come with a kit. The overlay of SI black adhesive is intentional. Several coats of SI adhesive will be placed over the surface of the patch and edges. This will serve to strengthen and build up the patch material as well as coverage over the edges onto the tank. This layered shell of SI adhesive black will form a barrier to the elements as well as additional strength and flexibility to the patch. This barrier and buildup assure the permanence of this repair. Note the generous amount of SI adhesive applied to the squeegee. This enables a smooth and fluid application of the adhesive in this overhead or in-position repair. There really is no other way than to apply this with the squeegee. Since Tech-Bond prefers not to use a squeegee for these overlay coats, this is something we elected to do based on the position of the repair. To compensate, no pressure is applied. This is merely applying the adhesive smoothly. Be certain to keep the squeegee free of drying adhesive. Do not mix or mingle dry adhesive with the liquid. Clean off the squeegee as often as necessary. Any mixture of SI black and activator accelerator will cause immediate drying of the material. Despite the awkwardness of working overhead, we managed to keep the materials separated. Make sure the perimeter of the patch is bonded thoroughly and smoothly. In a familiar pattern, we apply activator accelerator to the SI black adhesive. The activator accelerator dries rapidly, and we again apply heat using the warm-to-touch approach. Heat from the chemical reaction will go on for some time. Avoid overheating. The warm-to-touch approach is sufficient heat. The exothermic chemical process will generate heat on its own. With several layers of strong, flexible shell, this patch is now ready to put in service. Given the flexibility of a fuel tank, we will wait several hours before moving the vehicle. Although ready for service, this patch repair will cure for up to 30 days before it reaches full strength. After a reasonably thorough cure, we paint the surface of the tank for cosmetic reasons and also to seal this area from the elements. We plan to protect this renewed tank with a metal skid plate. There are many aftermarket fuel tank skid plates available for the Jeep Cherokee, and this tank repair, if protected by a skid plate, should last as long as the vehicle.